Electric circuits. This is the wide title that we are going to go through and talk about in this course. So let's begin with the definition of electric circuits. What are electric circuits? They are the assemblage of devices and equipment needed to connect the source of energy to the user or the device which exploits it. This means that I have certain elements of the circuit that needs energy to work properly, and these are represented as black boxes in front of you. And I have another elements of the circuits that supply energy to the circuit. These are defined as active elements of the circuit or passive elements. Voltage sources and current sources are examples of the active elements, whereas resistors, inductors, and capacitors are examples of the passive elements. Let's start by talking about the energy sources, specifically the voltage source. Here we can talk about what we call the ideal voltage source, which is symbolized like this. This is the source that is independent of the current that passes through it, which means it can maintain a fixed voltage independent of the load resistance, which means independent of what devices are connected in the circuit, or the output current. For example, if a thicker wire is connected at the terminals of this source, more current will flow in the circuit, however, the voltage will remain constant. The same voltage will be supplied to the circuit by this source. Another thing that we can talk about here is the electric potential difference. It is defined between 2 points as being the work required to move a unit positive charge, which is 1 coulomb of charge, between them. So, the voltage or the potential difference can be written as work per charge. The unit of electric potential is called the volts. A potential difference of 1 volt exists between 2 points when 1 joule of work is required to move 1 coulomb from the point of lower potential to that of higher potential. Lower potential means more negative charges, however, higher potential means more positive charges or less negative charges. Now we will talk about the current source. Here we can also talk about what we call the ideal current source, which is represented like this, or simply with a circle having an arrow inside it that indicates the direction of current. The ideal current source is independent of the voltage across it. This means the value of the current will remain constant with respect to time and load resistance. A steady flow of electric charges is called the direct current. When 1 coulomb of charge passes a given plane of reference in 1 second, it represents a current of 1 ampere. As a summary, I, which is the current, is the rate of change of charge and can be written as I is equal to dq, which is the change of charge with respect to time, which is over dt.